So, the last of our popcorn sessions, if you like, today. And I'd like to welcome to the stage Yannik from Arcium, who will be talking to us one of my favourite titles of the day, Encrypt Everything and Compute Anything.
Tremendous.
All right, yeah. Hi, everyone. I'm Yannik, co-founder and CEO at Arcium. And with Arcium, what we are trying to achieve, to establish, is for everything to be encrypted and anything to be computed on top of that encrypted state. And so what we are building is the global supercomputer for a hyper-encrypted internet. And the hyper-encrypted internet is an internet in which there's confidentiality for any app on top of any network with any kind of computation. And that's incredibly significant because one of the main hindrances for mainstream adoption of crypto, and we are in a good market right now, but still the technology that we are building, the apps that we are building, haven't found any significant adoption. So in order to have mainstream adoption, in order to have big players, institutionals use this kind of technology, we need confidentiality. But I like to think about it more as a positive feature instead of thinking about privacy needs to be added. Privacy always feels like this afterthought that hinders innovation because it seems to make things slower and more complex. So the incredible thing we are able to achieve with confidential computing and this kind of confidentiality is making apps way more powerful. So we can build way more powerful DeFi, way more powerful DePIN, and enable entirely new use cases on distributed systems, like, for example, confidential decentralized AI. And so what Arcium is, at its core, is a stateless, purely computational network. And for us, this decision has been very conscious to not make Arcium its dedicated blockchain, but instead a sort of co-processor that allows for confidential computations to be executed within Arcium on top of different networks. And so existing blockchain networks sort of serve as consensus and state layers for our network. And on top of those networks, we are running parallelized on-chain mempools with local fee markets for the orchestration and coordination of confidential computations that are then being executed within Arcium. And so confidential computing in the context of Arcium means confidential computing through secure multi-party computation. And once those secure multi-party computations that we execute within Arcium have been settled, that settlement then occurs back on the corresponding layers where the original computation requests originated from. And on top of that, we've introduced a new kind of censorship resistance for those confidential computations in order to allow them to fulfill what these kind of decentralized applications require, especially in terms of DeFi. And so what we're doing with Arcium is Arcium takes encrypted state, transforms that encrypted state, runs multi-party computations, and then settles back encrypted or plain text values to the corresponding blockchain networks. And the secret sauce behind all of that is MPC, and our MPC protocol, Cerberus, operates in the pre-processing model, which for execution is the most efficient kind of MPC. And we are using MPC in the pre-processing model together with somewhat homomorphic encryption, allowing for way faster execution than the usual go-to cryptographic solution, which would be fully homomorphic encryption. And we operate in this setting with a trust assumption. We want to have confidentiality, but since we're using MPC, we need to have some sort of trust assumption. And in our case, we had this conscious decision to opt into the smallest possible trust assumption we can have in a distributed system, which is the so-called dishonest majority trust assumption, only requiring one single honest participant being part of our multi-party computation to behave honestly, to behave according to protocol. And that's a very significant paradigm shift from what we're usually seeing with blockchain networks, right? With normal blockchain networks, we are always operating in the honest majority setting. With practical Byzantine fault tolerance, we expect 2/3 of participants to behave according to protocol, but that's not something that we would want when we are handling sensitive data, when we are handling execution that should happen in a fully confidential way. And that's why we have this 1 out of n trust assumption, this trust assumption that only requires one single honest participant in an arbitrarily large set of nodes that run such a computation. And we've overcome some of the practical limitations of these kinds of MPC approaches, which is censorship, by introducing an identifiable abort protocol into Arcium and combining that with a staking and slashing mechanism, adding accountability to the nodes that are tasked with running those confidential computations. And on top of that, we are introducing oblivious sorting and oblivious data structures that allows us to process larger amounts of data than otherwise would be possible. And so what we've done is we've designed our execution engine, which is ArcOS, our distributed confidential operating system, on top of which users can create virtual isolated environments, MXEs, MPC execution environments, and we've designed a custom compiler, Arcus, that allows any program a developer has already built to be compiled into a format that our network understands and can process in a confidential way. And with Arcus, we allow for confidential smart contracts and confidential machine learning with our Python variant. Something I'd like to share with you guys is that, just last week, we announced our acquisition of our largest Web2 competitor, who've been around for more than 8 years, doing a lot of foundational research and development in the MPC and confidential AI space. And they have really been the leader in building out these systems and working with governments and enterprises in TradFi, defense, and healthcare to bring confidential computing to those industries. And we've integrated that technology into Arcium, combined that with our existing protocols, open sourcing the patents, allowing for this kind of confidential computing to now be accessible in this new approach to confidential computing. This approach of confidential computing of not having any kind of single trusted actor involved, removing all trust, instead building a foundational networking layer for the internet to operate over. And so what we are able to do with confidential AI and more precisely confidential machine learning now is confidential training and inference, federated learning. And what I want to highlight in the context of confidential AI really is that if someone wants to build decentralized AI using blockchain networks without this kind of confidential computing, it's impossible to realize this vision. Because in order to create economic incentives for a data economy, for a training economy, and also for an economy of AI agents, it's required to have those confidential execution environments within which data can be used in this sort of end-to-end encrypted way, where the training, the model weights, and the inference all happen in a fully encrypted way. So yeah, that's what we're trying to achieve with Arcium. That's what we are building. As we like to say in the Arcium community, GMPC.